Hi, I'm Zahir Afifi bin Shamsul, AA 250103. So I would like to presenting about introduction of arithmetic sequence and series and geometric sequence and series. Let's go through the arithmetic sequence and series. Arithmetic sequence is sequence that has the property that the difference between any two consecutive terms is a constant. In other words, a sequence of numbers such that the difference from new term to initial term remains constant throughout the sequence. This constant is called the common difference. For example, 2, 4, 6, 8, and 10 is a progression with a common difference of 2. So what about arithmetic series? Arithmetic series is the sum of the terms of an arithmetic sequence. Next, geometric sequence and series. First, geometric sequence is one in which any term divided by the previous term is a constant. This constant is called the common ratio of the sequence. The common ratio can be found by dividing any term in the sequence by the previous term. For example, 4 divided by 2 and 2 divided by 1 is a common ratio of 2 because the ratio is constant. So, what about geometric series? Geometric series is the sum of the terms in geometric sequence. So, how can we apply arithmetic and geometric sequence and series? We can apply this in solar farm installation as we have assigned to solve the study case number 7. Besides, we can also apply in street light along the road, seating rows, and battery storage capacity degradation. As a conclusion, sequences play an important role in real life as they help us identify and predict patterns in an organized way. Understanding sequence allows engineers and planners to design systems more efficiently, make accurate prediction, and optimize resources in real-world application.
Alright, so to continue our today's discussion, I will talk about our case study overview. So for our group, we are assigned for case study 7, which are solar panel rows. So there are two methods of arranging solar panels here, which the first being increased by a fixed amount, which has 4 panels. So this form an arithmetic sequence. For the next arrangements are increased by a fixed percentage, which are 10% more than the last panel. So this forms a geometric sequence. So by modeling formulas and determining the total number of panels in the first 12 rows, this case studies demonstrates how different growth patterns influence overall panel distribution. Alright, so moving on, I will talk about our manual solution, which are the solution that we counted with using our bare hands. So for the first task, we are assigned to calculate the formula for the number of panels in row n, which n represents the certain positions for a number. So for the first arrangement, the arithmetic sequence, the first row is given a equals to 10. And then for the common difference, or you can say that the difference between the current row and the previous row, which is d, equals to 4. So with that being said, we can just substitute all the information we had into this given formula. So which is an equals to a plus bracket n minus 1 bracket times d. So for the second arrangement is the geometric sequence. So for the first row is also given a, which is 10. Then for the common ratio, which is r, or the difference between the current row and the previous row, is given to 10%. So basically it means that 1.10% we have to 100 plus 10. So for the formula, it is not like the arithmetic sequence. It is instead an equals to a times r to the power n minus 1. Right, so for the second task, we have to calculate the total number of panels in the first 12 rows. So with that being said, we have to calculate the total. So we have to use a different kind of formula. Because unlike the previous formula is used to find a certain number of the panels in a certain row. So for example, maybe like you want to find how many panels are there in the first row, or the second row, or third row. While the second asks us to find the total. So starting from 1 until 9. 2, 12 or any. So with that being said, for the first arrangement, which is the arithmetic sequence, we have to find the 12, the first 12. So it is given here that the formula is Sn equals to n divided by 2, bracket 2 times a plus bracket n minus 1, bracket times d. So with that being said, we have to substitute everything in. So while n being 12, as we want to find the first 12 rows. So and then for a, which is 10, and then d equals to 4. So after substituting everything, we'll end up with 384 panels in row 1 until 12. So basically it's combined everything from 1 till 12. So for the next arrangement, which is the second arrangement, the geometric sequence, we'll use a different kind of formula. So for this we have the given formula here is that Sn equals to a times to r to the power of n minus 1 divided by r minus 1. So just like the previous formula, this is also to find the total number of panels. So a being 10 and n being 12. So after substituting everything, we end up with 240 panels. So that's all from me. Thank you. So for further discussion, we will continue by our next group member.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Haji. Matrix number AA251181. I will be talking about our Excel solution. For the first arrangement, an arithmetic sequence was used with initial value A equals to 10, common difference D equals to 4, and number of terms and ranges from 1 to 12. All the values entered to Excel and arithmetic sequence was applied to generate each term automatically with increase of 4 for each successive term. For the second arrangement, a geometric sequence was used with initial value A equals to 10, common ratio R equals to 1.1, and number of terms N ranged from 1 to 12. All the values entered to Excel and geometric sequence was applied to generate each term automatically.
As for the reflection, this is what we learned throughout this project. Based on the task given, we learned how to evaluate mathematical concepts in engineering problems effectively in a well-structured group where each of us were able to contribute to exchange a different view of strategy. Furthermore, we utilized appropriate mathematical techniques as a gear to evolve engineering problems. And this is benefits that we have gained throughout this project. Solving mathematical questions that involve real engineering problems enhances our ability to analyze problems logically as well as systematically. By interpreting given data, choosing appropriate formulas, and applying suitable methods, we develop structured thinking that is useful in both academic and real-world situations. So, thank you.